welcome to Cambridge Chemistry channel with sarwatAhmed. In this video I will discuss the relative mass of atom and molecule or mole calculation, atoms, molecules and stoichiometric calculations of the 9701 topic, and these are the important past paper questions from 15 till 21, 2015 till 2022. So these are the questions from the past paper. So let's start. First question So this is a question relative masses of atoms and molecules, 2.1 unit. Question number this is question number 4 of March 21, question paper 1-2. Originally chemists thought indium oxide had the formula indium oxide. By experiment they showed that 4.8 gram of indium combined with 1 gram of oxygen to produce 5.8 gram of indium oxide. This is very simple question to calculate the air of oxygen was choosing. So this is how to calculate this question. Indium, the mass of indium, this is mass of indium. This is by using mass over air. This is mass of oxygen and AR of oxygen, and this is mass of indium and AR of indium. So in this way we can calculate the AR of indium by doing cross multiplying. We get the value AR is equal to 4.8 into 16, which is equal to 76.8 or approximately 77. So B option is correct option. Which statement is correct? Next question is from October-November 20, question paper 1-1. Question number 1. Which statement is correct? Chlorine has a relative isotopic, not isotopic, this is atomic mass of 35.5. Chlorine Cl2 has a relative molecular mass of 70, which is equal to 71. So 35 Cl2 is the molecule, so 35.5 into 2 is equal to 71. ICl has a relative molecular mass of 162.4, so it is equal to iodine is 126.9 plus 35.5, which is equal to 162.4. So this is the correct option. And sodium chloride has a relative molecular. Sodium chloride is ionic compound, so that its formula is not molecular mass. It's has a formula mass of 58.5. So next question, the mole and Avogadro constant, which contain the largest number of hydrogen atoms, 0.10 mole of pentane. We know that the mole is how to calculate the number of molecules or number of atoms. So these are the by using mole into Avogadro constant. So 0.10 is the mole and number of hydrogen atom in pentane C5H12, the number of hydrogen atom is 12, so into 6.02 into 23. So 0.20 mole of butene. So butene is the C4H8, 0.20 into 8 into 6.02 into 10 raised by 23. Similarly 6.02 of hydrogen atoms. Hydrogen atom is 1, so 1 into 2 into 6.02 into 10 raised by 23. So the answer is 0.1 into 6.02 into 10 raised by 23 is equal to this is equal to 6.02 into 10 raised by 22, and next is 0.20 into 8 into 6.02 into 10 raised by 23. So this is equal to 9.632 into 10 raised by 23. So this is 1 into 2 into 6.02, 1 into 2 into hydrogen molecules. Hydrogen molecule is H2. So 1 into 2 into 6.02 into 10 raised by 23. This is equal to 1.2 into 10 raised by 24. And this is 1.602. This is equal to, D option is equal to 6.02 into 10 raised by 23. So this option is correct option. C option is correct. So this is a way how to calculate such type of questions, in which you have to calculate mole of atom, the mole of molecules, by using this formula. So next question is, which statement about the Avogadro constant is correct? It is the mass of 1 mole of any element. No, this is incorrect. It is the mass of 6.02 into 10 raised by 23 atoms of any element. No, it is not correct. This is not a mass, it is the number of particles. So that's why these two options are incorrect. It is the number of atoms in 1 mole of. This is correct option. C is the correct option. It is the number of atoms in 12 gram of any element. This is also incorrect. Not any element. 1 mole of any element contain 6.02 into 10 raised by 23 number of atoms, number of molecules. So next question is, which statement is correct? 1 gram of hydrogen gas contain 1 gram of hydrogen gas contains 3 into 10 raised by 23 atoms. 4 gram of helium gas contain 1.2 into 10 raised by 24. So first calculate the MR mole, and then calculate like this. So you can calculate like this, 0.5, and this is 4 divided by 4 into 6.02 into 10 raised by 23. This is 16 over 16 into 6.02 into 10 raised by 23. 16 gram atoms, 44 gram of carbon dioxide contain 44 into 6.02 into 10 raised by 23. So this is 0.5 into 6.02, 0.5 into 6.02 into 10 raised by 23. This is the 1 gram of hydrogen gas contain 3 into 10 raised by 23 number of atoms. So this is correct option. 4 gram, it is incorrect. This is also 16 gram. This is also incorrect. So 1 into 6.02. 44 gram of carbon dioxide contains 6.02 into 10 raised power 23. So this is also incorrect. So A option is correct option. A sample of solid ammonium chloride decomposes on heating solid ammonium chloride to form ammonia gas plus hydrogen chloride. A total of 2.40 into 10 raised by 21 molecules of gas is formed. How many hydrogen atoms are present in the gaseous product? Hydrogen over here, ammonia, this is ammonia, and this is HCl. So total number of hydrogen atoms are 4 hydrogen atom. If 1 contain 2.4 into 10 raised by 20, so what would be the hydrogen atoms are present in the gaseous 4 ratio x. So this is equal, the best option is 9.6 into 10 raised by 21. This is the best option. Next question from Winter 19, question paper 1-1. Question 2. Diamond is a pure form of carbon. The mass of diamond can be measured in carats. 1 carat is 0.200 gram of carbon. Which expression gives the number of carats that contains 6.02 into 10 raised by 23 carbon atoms? So 1 carat is equal to 12 grams. So what would be the 0. Carat in 0.200 gram of X? So this is like this, 1 into 0.12 gram. Diamond is a pure form of carbon in carats. Mass of diamond can be measured in carats. 1 carat is 0.22 gram of carbon. This is this, and 0.22 gram. 1 carat is equal to, 1 carat is equal to 0.200, and what would be the 12 gram contain X. So this is equal to 12 divided by 0.200. So this is the best option. Next question is sports medal has total surface area 150 centimeter cube. It was evenly coated with silver by electrolysis. Its mass increased by 0.216 gram. How many atoms of silver was deposited per centimeter square on the surface of the metal? So how to calculate this question? So 0.216 gram of its mass increased by 0.216 silver by electrolysis. So mole of silver is equal to 0.216 divided by 108. This is equal to 2 into 10 raised to minus 3 mole. So 2 moles has 6.02 into 10 raised to 23. So what would be the moles of what would be the number of particles if we have 2 into 10 raised minus 3 mole? So ratio X, and this is equal to 1.20 into 10 raised 21 by using cross multiply with it. Now 150 centimeter cube sports medal has a total surface area of 1 centimeter cube. It was evenly coated with silver by electrolysis. So 150 centimeter cube, it means cover 1.20 into 10 raised by 21, and what would be 1 centimeter cube square? By cross multiplying, this is equal to 8 into 10 raised per 18. So A option is correct option. So next question is which would contain 9.03 into 10 raised by 23 oxygen atom. So the question is solved by using the same method which I have discussed earlier. Like 0.5 aluminum oxide, this is Al2O3. So 0.25 number of atom of oxygen is 3 into 6.02 into 10 raised by 23, and this is sulfur dioxide. 0.75 mole into number of atom is 2 into 6.02 into 10 raised by 23. Similarly, sulfur trioxide 1.5 into 3 into 6.02 into 10 raised by 23. Similarly, 3 moles of water is equal to 3 into water has 1 oxygen atom, 6.02 into 10 raised by 23. So let's calculate. Hmm. 0.25 into 3 into 6.02 into 10 raised by 23 is equal to 4.52 into 10 raised by 23. Similarly, 0.75 into 2 into 6.02 into 10 23. So this is equal to 9.03 into 10 raised by 23. So B is the correct option. So next question is compound X formulas. So this is from March 22, question paper 1, 2 and question 3. Compound X contains the element C carbon. This is very simple question by calculating the empirical formula. So carbon, hydrogen, oxygen. 2 gram of X produces 4 gram carbon, 4 gram carbon dioxide and 1.63 gram of. So first of all, calculate the number of carbon atoms. So how to calculate the number of carbon atoms in carbon dioxide? So mass of carbon is equal to 4 gram divided by 44 into 12. 4 divided by 44 is equal to into 12. So this is equal to 1.09. Mass of hydrogen is equal to 1.63 divided by mR of water is 18 into hydrogen 1. So 1.63 divided by 18 is equal to 0.905. So this is the mass of hydrogen. So what would be the mass of oxygen now? So mass of carbon plus hydrogen is equal to 1.09 plus 0.905. 1.09 plus 0.905 is equal to 1.995. This is carbon, hydrogen, and mass of oxygen by subtracting 2 gram minus 1.995. So 2 minus 1.995, it is equal to 0.005 gram. So mass of carbon is this, mass of hydrogen is this, and mass of oxygen is this. Now by using these masses we calculate the empirical formula. Carbon, hydrogen and oxygen. Mass of carbon is 1.09, 0.905 and 0.005 divided by 16 divided by 1 divided by 12. 1.09 divided by 12, it is equal to 0.0908, ratio 0.905, ratio 0.005 divided by 16. This is equal to 0.00312. So this is the 0.00312. This is equal to 1. This is 0.905 divided by 0.00312. So this is not the way we calculate. This is long calculation. So we can calculate like this. For example, compound X plus O2 to form CO2 plus water. So 4 gram of carbon dioxide divided by 44 and 1.63 divided by 18. This is 0.090 and this is equal to 0.0906, and by subtracting 0.0906, 44 4 divided by 44. This is equal to 0.0909, and 0.0909 plus 0.0906 is equal to 0.18 minus 2. This is equal to 1.8. So we calculate this question like this. So we know that this is a 2 gram of X produces 4 gram of carbon dioxide. So we calculate number of moles of carbon dioxide. 4 over 44 is equal to 0.090. Similarly, mole of water is equal to 1.63 divided by 18. This is equal to 0.090. So let's calculate CH2. We know that 2 gram of X. CH2 is the 2 divided by Mr, carbon 12, hydrogen 1, oxygen 32, this is 45. It is equal to 0.044, and this is 12 into 2 plus 2 plus 16. This is equal to 42. 2 divided by 42 is equal to 0.047 mole, and C is 2 divided by 12 into 2 plus 4 plus 16. This is equal to 244, and the answer is 0.045. Similarly, this is equal to 12 plus 2 plus 32 equal to 46, and 2 over 46 is equal to 0.043. Now by using reaction, for example, if CHO2 plus O2 to form carbon dioxide and water, so this is 1:1, so the mole is 0.044, which is not the mole of 0.09. So that's why this is incorrect option. Now next is C2H2O plus O2 to form carbon dioxide and water. So by balancing this reaction 2 over here, so carbon dioxide is 1:2 and 0.047 ratio X. The mole would be equal to 0.094, which is not the correct option, so that's why it is incorrect. Similarly, next C2H4O plus O2 to form carbon dioxide and water. So by balancing this equation, 2 over here and 4 2 over here, so 2 2s are 4 and 2 6, so place 3 over here, so 1:2, and this is C2H4 is 0.045 mole, 0.045 ratio X, that is equal to 0.090 mole. And similarly 1:2 of water, so the same moles in case of water 0.090, which is equal to carbon dioxide mole and water mole. So the C is the best option. The next question is which statement about atoms and molecule is correct. The molecular formula of compound is the simplest whole number ratio of atoms of each element in the compound. Molecules is correct. The molecular formula of compound is the simplest whole number, so this is not the simplest whole number ratio of atoms, so this is incorrect. 1 mole of any substance contains 6 into 10 raised by 23 atoms. Any sub 6.02 into 10 raised by 23 number of particles, not atoms. So 1 mole of any substance, so could be molecule, substance could be molecule, ion, atom or compound, so that's why it is also incorrect. The relative atomic mass of an element is the ratio of the average mass of one atom of the element, average mass of one atom of the element to the mass of an atom to the 1/12 of mass of an atom, C12 isotopes. So this is also incorrect. The relative formula mass of compound is the sum of the individual atomic masses of all the atoms in the formula. So this is the correct option. So this is very simple question. Compound X is an organic compound that contains 30.6 gram carbon, 3.8% hydrogen and 20.4% oxygen, 45.2% chlorine by mass. What is the empirical formula like this? You can calculate like this: carbon ratio hydrogen ratio oxygen ratio chlorine. So this is 30.6, 3.8, 20.4 and 45.2. This is divided by 12, this is divided by 1, this is divided by 16, this is 35.5. So by using mole ratio we get the formula, so you can easily calculate this question, I think so. So this is 2.55, this is 3.8, this is equal to 1.275 and this is 1.273. This is smallest value, 1.273 divided by 1.273, this is divided by 1.273, 1.273. So this is equal to 2, this is equal to 3, this is equal to 1 and this is equal to 1. The answer is C2H3OCl. A option is the next question is compound J burns in excess of oxygen to give carbon dioxide and water only. When a 3 gram sample of compound J is burned in excess oxygen, 4.40 gram carbon dioxide and 1.80 gram of water are formed. What is empirical formula of J? This is 4.40 divided by 44, this is equal to 0.1 and this is water, mass of water 1.80 into divided by 18 is equal to 0.1. So this is the mole of and this is 3 grams. So by using the same method which I have discussed earlier, 3 divided by 23, this is a 0.23 mole, 3 over 29, 0.103, 3 over 14, 0.214, 3 over 30 is equal to 0.1 mole. So we have CXHYO2. J burns in excess of oxygen give carbon dioxide and water only. When 3 gram of sample J burn, carbon dioxide of water are formed. What is the formula of J? This is how to calculate like this: CXHYO2. For example, if we have this by using this CXHYO, So this is 0.1 mole of carbon dioxide and 0.1. So in this equation, in this reaction, we have 0.1 mole of carbon dioxide and 0.1 mole of water. So this is also 0.1 CH2O. This is CH2O. CH2O plus oxygen. So 2 is balanced, carbon is balanced, oxygen 2 and 3 and 2 and 3. So 0.1 mole, we have 0.1 mole in this case, 3 over 30 is equal to 0.1 mole. So 0.1 mole of carbon dioxide is produced, 0.1 mole of water is produced. So over here 3 moles of compound. So this is 3 moles of compound when by solving 3 moles of compound. So this is 3 grams and divided by CH2 30, this is equal to 0.1. So this option is correct option, D option, CH2O. So you can check rest of the chemical equation like this. If the answer is 0.1, then you can check, you can verify that these all 3 options are incorrect. Next question, compound J and K each contain 40% carbon by mass. What could be J and K be? So this is glucose 180 of the glucose, and this is C6H10O5N. So 180 40%, 180 contain 40% carbon of 40% carbon by mass in this compound 180. The MR of glucose is 180. So this is 40 and 100 contain X. So (40 into 100 divided by 180). 40 into 'So by using this like this, so we have 12 carbon atom and into 6 is the number of carbon atom, 12 is the AR and divided by 180 is the MR of compound. So this is equal to 40%. 12 into 6 divided by 180 is equal to into 100 is equal to 40. This is equal to 140 and C6H10O5. This is equal to C6H10, 12 into 6 plus 12, 10 plus oxygen 5, 16 into 5. So 12 into 6 plus 10 plus 16 into 5 is equal to 162. 12 into 6 divided by 162 into 100. So 12 into 6 divided by 162 is equal to 0.44 into 100. So this is equal to 44, so which is incorrect, so this is incorrect. So C5H10, this is 40% correct, and C5H10O5, this is equal to 12, 60, 10 and 5, 16 5s are 80, so this is 150. 12 into 5 divided by 150 is equal to 0.4 into 100 is equal to 40. So this is also equal to 40%. So that's why B option is correct. You can verify, you can check other options like this. This is C6H10O5, this is C6H12O6, and this is C5H10O5. These two pentose and hexose contain the 40% biomass of carbon. Which formula represents the empirical formula of compound? Which formula represents the empirical formula of a compound? C2H4O is the empirical formula because 2 1s are 2, 2 1s are 2, 2 1s are 2. CH2O is the empirical formula in this case CH2, in this case CHO. So C2H4O is the empirical and molecular formula of the compound. So next, two hydrocarbons have the formula CWX and CYZ. WXY and Z represent different whole number. So W over X is equal to Y over Z. Which row is correct when comparing the two hydrocarbons? Empirical formula different, this is incorrect. Molecular formula different होना चाहिए, and this is also should be different. Different, no, this would be same, this would be different, this would be different. So the empirical formula would be same, molecular formula would be different, relative molecular mass would be different. So C is the best option.